This is a quick introduction to Experiment 4, Chloride Determination by Precipitation Titration. The goal of this experiment is to determine the percent chloride by mass in an unknown solid sample. The method that you're going to use is a precipitation titration. So you're looking for the formation of an insoluble precipitate, silver chloride, and a resulting color change from that. So the reaction of interest is the precipitation reaction of silver chloride. So the reaction you see here has a very small KSP, indicating that when a silver ion and a chloride ion are in aqueous solution, they will form this precipitate. The indicator that you're going to use is dichlorofluorocene, which makes a complex with the precipitate and with dextrin. In a solution with no free silver ions, the solution will be colorless. It'll start out as actually a green color. You'll see a pink color forming when there are free silver ions in solution, meaning that all of the chloride is bound up as silver chloride and there are free silver ions left over. The materials that you need for this, some solutions that will be in the hood and on your benches, are the dextrin and the dichlorofluorocene, which are the indicators, and a sodium chloride solution. This is your primary standard. There's going to be a concentration on the bottle. You need to make sure that you write that down. It will not be the number you see here. It'll be some different solution. In addition to this, your weigh bottle that you left at the end of experiment 3 will have silver nitrate, which you'll use to make your titrant solution. And you'll also get an unknown in a small unknown bottle. The first thing you're going to need to do after you make your titrant is prepare your titration flasks. So you're going to pipette exactly 10 milliliters, or your calibrated volume, of your chloride standard into your titration flasks. You're going to add water to bring the total volume to 50 milliliters. So for your standardization, you're going to add 40 milliliters of water. For your unknown determination, when you're using a solid chloride sample, you're going to add 50 milliliters of water. You're then going to add 10 milliliters of dextrin. The exact volume is not important, so you can do this step with a graduated cylinder. Once you've added the dextrin to your titration flasks, you'll add the dichlorofluorocene indicator, and it'll turn this green-yellow color. As you start the titration, this yellow color is going to start to get sort of cloudy and dull, and this is due to the formation of your silver chloride precipitate. The color that you're looking for, it's sort of blurry here, is this rose pink color, and so at a certain point after maybe 10 or 15 milliliters of titrant, you'll be able to see a significant amount of this pink color forming around where the stream from the burette is entering your titration flask. It's difficult to see in a picture, but the point at which this pink is faint and persistent throughout the entire flask is your endpoint. Looking at it in this picture, it sort of seems milky white, and it is, but there is a pink hue to it. That's what you're looking for. If you go too far, it'll turn into sort of a Pepto-Bismol color, and this is what you don't want. This is far too much pink. This pink color will actually start to get dull and turn to a little bit of purple after it sits on the counter for a while, so you should not have a flask where you think the endpoint is good, have it sit there until your next titration, and then compare, because the color will change over time due to photo degradation of the nitrate. So don't try to make that comparison. Evaluate each individual endpoint on its own. Your data analysis is going to be sort of the standard two parts. For the standardization part of the experiment, you're going to calculate the number of moles of chloride added based on the volume of your pipette and the concentration of the sodium chloride solution. You're going to use your balanced chemical equation to find the moles of silver that you delivered with the burette. So you're going to find the moles of chloride, figure out how many moles of silver you delivered at the equivalence point, and then use that number and the volume delivered to find the molarity. Once you've standardized your titrant, you can do the opposite process for the unknown determination. Calculate the number of moles of silver that you delivered with your burette, use the balanced chemical equation to find the moles of chloride, and then find the mass of chloride and use the mass of the unknown to find the percent composition. Your accuracy grade for this experiment is going to actually be in two parts this time. One of these is for the unknown determination. The other is on your ability to make your titrant correctly using the analytical balance and the volumetric glassware. If you make your silver nitrate titrant correctly, since it's a primary standard, you should be able to get an exact concentration, the same number as you get for your standardization. You should be able to get from the analytical balance. So what you'll do is you'll report on your data sheet how much silver nitrate you weighed out, what the concentration of your titrant should be based on that number, and then what it should be based on your standardization with the chloride standard. And you'll compare those two numbers. That's going to be part of your accuracy grade.